I just want everybody just look around. If somebody's sleeping, just wake them up. Because I think the presentation I have is so important, you cannot miss it. So I'm in Boehringer Ingelheim. I'm in the data integration and logistics service group. I've been BI for 4 years. So the title is basically a reaction schema. First of all, I want to spend a few minutes to tell what is BI, because BI is kind of a middle range of a pharmaceutical company. A lot of people know, but doesn't really know what this company is about. So BI, Boehringer Ingelheim, is a human pharmaceutical and animal health company. Of course, we have a lot of chemical, a lot of other business. But we are owned by family. Boehringer family owns the company so far. For more than 100 years. In 1885, they established this company in the small town called Ingelheim. That's how we call the Boehringer Ingelheim come from. So right now we have employee about more than 40,000. We do have revenue about 13 billion euro. We spend up 2.2 billion in the research and development right now. We have 4 pharmaceutical research sites we call OPUs. In US, Ridgefield, Connecticut. In Germany, actually 5. Germany has 2, Biberach is a major one, and we also have Ingelheim have some research too. We have Vienna in Austria and Laval in Canada. And I'm sorry, Milan in Italy also has a group of research. We are focused on the 6 therapeutic areas. The big one is respiratory disease. We have several drugs on the market, mainly from Biberach Center. We also have a cardiometabolic, which is Biberach and Ridgefield. Oncology is mainly focused in Vienna. And neurological disease is Biberach, and also inflammation immunology in US, and Canada is exclusively working on the virology and HIV things, HCV or something like that. In last couple of years, BI is doing okay. In 2010, FDA approved the Parser, which is considered the first drug approval in last 50 years to compete with warfarin, which requires drug test and blood test every week. And the Parser is oral pills, and you don't need a test. So it's a lot easy for the patients. So this is a big one. Last year, again, we've been another medicine being approved in diabetes type 2. This is the first approval in the collaboration between BI and Eli Lilly. We have several in pipeline for this collaboration. Okay, so the topic today is when I develop a software made specifically for CRO outsourcing. So I want to switch the gear here, talking about CRO, why we have CRO. Probably everybody already knows that I quote this from the right side that Asia say, better by economic uncertainty and under pressure to deliver better medical products in more cost-effective way. Pharmaceutical now are increasingly driven to outsourcing their research R&D to CROs. I think everybody understands, everybody knows, this is the trend. We just cannot easily reverse this trend. So we have to work with it. try to collaborate with it. In BI, we have, in terms of chemistry collaborations, we have 3 categories. The first, level 1, basically, we are ordering compound. We get an SD file, and we buy the compound and say, see you later. That's it. The second level is actual collaboration partners. We have signed a contract with partners, and they synthesize compound for BI. Therefore, we have a lot of interactions. We need all the compounds through secure electronic media. And another level, the high level, is, of course, research partners. We do have something like that. People not only synthesize compound for us, but we also do research with us. In that case, intellectual property will be shared. They will be managed by both sides. Now, today's system is mainly for the middle level. Okay, so the system I developed called the ERMS, External Request Management System. In pre-ERM situation, we actually manage the request in the spreadsheet. And we put in the shared room so we can, the CRO can see it. Of course, this creates a lot of troubles, a lot of issues. First of all, when we evaluate CRO's performance, each different OPU, because we are, different research OPU, they manage it by themselves. So it's very difficult to have a consistent matrix calculation to evaluate which CRO will do better job than another one. Of course, there's no streamlined system to control the process. And most importantly, we have seen a redundant request happening, either from different CROs or different project managers, because there's no communication. And, ask them synthesize compound costs many dollars. Of course, this should not happen. And actually, the CRO reported us, say, hey, you guys already since the last year, you should have enough compound to test. So that's kind of situation. Another situation is even the same compound because requested from different channel, and actually the synthesis schema is different. So they found that too. A lot of other issues, for example, when you want to generate a report from a spreadsheet, you have to manually do it. Or maybe, at that time, definitely they do manually. When we receive compound from CROs, you have to manually register into the register system. Of course, we always have trouble to track how many FTEs in different CROs because there was no database at that time. So, of course, we need an assistant to do this kind of thing. So this illustrates what the process in the beginning was. So BR chemist. Which one? Okay. The BR chemist put the request in there in the spreadsheet. CRO sees that they start a process and send it back, and we register in the inventory system. Manager calculate metrics to evaluate the efficiency of CROs, and the shipping information has to go to FedEx, whatever, try to find out where the compound is. Of course, the management, local or international, make decisions based on the manager's calculations. To replace this system with a system we call the ERMS here. It, of course, has a database. They have search tools, has a user interface, has a reporting feature. FedEx information is a web service. You can register web service in FedEx. So, and also the inventory registration will be automatically once they send it to us. They finish the synthesis. then automatically insert into our inventory. Okay. Now, in terms of system architecture, I think I discussed with several colleagues yesterday about how we can put the system in. Initially, we were thinking about try to put this system. There was two firewalls. It's external and internal. And this area we call the DMZ zone. And initially, we were thinking about put the system in DMZ zone. Therefore, CRO can come in to because CRO cannot get into this area. There's no way they can get into internal firewall. That was the initial thought. And we realized, we learned there was a new technology called SSL VPN, which you actually can use the VPN router to encrypt all the traffic and the information. And actually, you can put the system inside this router, just point a link to the system. So they can log in, they will see ERM's link. They click the link, they get into the system. That's very easy. So we not only we use this technology for the ERM system, we also, there was another we call the XLab system. Actually, we use the same technology right now. So this is very easy to implement. The only thing is just manage the router and they come in. The drawback of that is, of course, you need to manage all these users in CRO. They need a firewall key, the code. And of course, because the system is internal now, internal scientists can easily access. There's no problem at all. In terms of what feature we have, in the system, we do have, of course, a request management process, how to create, when to update status. Of course, we have a database to control all these things. We also have the structured search feature, not only search in ERMs, but also search of our internal database and even commercial database. I will explain why we needed that. And the system, of course, have a shipping status and logistics calculation, which is only open to BI. And those are open to partially, at least these are partially open to CRO. So, of course, the user authentication and authorization is a big deal there. So, okay, in terms of workflow, the first one, the user, when they register compound into and the synthesis scheme into the interface, and the system will automatically check the duplication. Based on our ERM system, we'll also check our compound library, reagent library, ELANs, and the commercial library, ACD or something like that. The reason we need to check all these things, not only we don't want to make a redundant compound, but also we want to make sure the compound is not appear in any of the internal database, or actually you can purchase from it, from whatever company already. Because if we can purchase, why need to wait and synthesize it? So that's the reason we have to check all this. The ELAN is basically we want to make sure we are not actually in the process of synthesize that internally. Of course, once this condition satisfied, then they will say, okay, how much I want, when I want, what purity, and how many synthesis steps when expected, because this will calculate the difficulty factor for us. So once this insert the database, then the project manager may assign whatever, project manager either in CRO or here in BI, assign whoever to do this job. And the chemist receive the job, synthesize and update status. And of course, email notification is going on always, let people know what the status is. The benefit of this whole system, there was a lot. Of course, we had realized the centralized user interface. The whole process was in the control now. Redundant, eliminated. Also, email notification, inquiry, better communicate with the CROs. We have, of course, structure search, make sure we're not doing something, redundant work. Also, there was a lot, we can timely manage the things because not report can generate automatically, or you can use a define whatever report you want. So all these things very easy. So it seems perfect. Okay, everything perfect. But we also definitely eventually we run into this problem. Where the challenge is we have recorded all these logistics and compound into database, except for the reaction scheme. It's very difficult. This is a user requirement. We have, of course, this is a fake reaction I downloaded from the internet. And David, don't challenge me my organic chemistry knowledge. I do have PhD, but I forgot all organic chemistry. So I don't know what this compound, what they synthesize. But I just take this example. What we're trying to do is, if a chemist draw this scheme, we want to do two things, three things maybe. One, we want to capture this information in the database. Two, we want to separate this compound into individual compounds so they can synthesize, they can select any of those compound things to do the synthesis. And ideally, we want a system be able to pass each individual reaction and store the reaction into our database. Because, just like the lady mentioned, there were sometimes we have our own reaction we want to keep in the database. That's the example we want to keep in the database. So in the first version of Hermes, we actually use MDL technology and work very well until that moment we want to do this, we realize that was not easy to do. So we choose ChemAxon technology. And we realized there was several benefits here. First of all, ChemAxon Marvin sketch allow you to generate any of image files. So at least you can capture the image in the database, and people can always see it eventually. So that's the first thing we did. Another thing is because we have a GACOM license, of course we can generate image through use programming, the Java program directly. So we can just insert that whatever the image we generate into database. So this is good. This achieve the first goal, which we want to capture this knowledge first. In addition to the image, we also use Marvin to save the chemistry format, save the chemistry reaction scheme. We realize use Marvin file that we can generate this whole scheme. Okay, by the way, this arrow is not a reaction arrow. It's just a single arrow. Okay, it's just draw arrow. Okay, I will come to that point later. But there's no way you can draw a continued reaction use a reaction arrow. Okay, but even using single arrow here, I can at least capture this image in the Marvin file format, and I can regenerate in next page or whatever. Regenerate this image. There was several try I did. First of all, try to use reaction file. What the result is only kept one the first reaction, and everything else either been considered as reactants or products. That's the behavior. If I use more file, of course you cannot use more file. But if you use more file, I get the whole as a mixture. That's the behavior we have. Okay. So as I said, what we want to do is first of all capture this image. Then we want a list of this compound, all possible compound, and let scientists select a few of those, and they want to synthesize those compounds. So in JCOM use the more file format. At least we get a mixture. So we can use what is called a get fragment. You can separate all the compound again. So this is actually working very well. This is very well. So we can at least separate compound. Okay. Now, as I mentioned, this is just a regular error, not reaction error. We have to do that. Okay. Now, the one thing I'm not sure about this is seems the order of a compound was a little bit. I don't know what the logic. I wish I can learn what the logic is, so I have a better control. But this is not a big deal. At least we listed all the compound there, at least. And the real challenge here is actually we really want is you have the scheme, then I want passing the scheme to individual reactions. And I can use these individual reactions and put in the database. So next time we can search that reactions. So the reality is, I would say, people in chemistry, our textbook also doing that. We draw a continuous reaction in one page. And the chemists are actually doing that on their whiteboard or their notebook. They're doing that. So I really think this is a very important use case. We possibly want to resolve that. If we can pass the reaction, regardless the direction of arrow, maybe up, down, right, left, whatever. Okay, that would be ideal. We also want to, of course, should retain the conditions, catalyst, solvent, whatever, in the reaction. I know this is not easy work. So I'm thinking, keep thinking about what we should do, what kind of suggestion I can make to you, to ChemAxon. So I'm kind of visionary person. I was thinking might be the solution of that. First of all, you draw the first reaction. And I noticed that if you draw second reaction, when you draw that, immediately will be some error or message or whatever. So when the user started to draw the second reaction, you already can check, okay, the one reaction law violate now. So once it violate, you might be evaluate the reaction, the previous reaction, say, okay, this is the reaction I see. Do you want to confirm that? Confirm it. Then continue to draw that, take the product as a reaction now, and for next reaction, now you can keep this reaction in the annotation or whatever. Okay, so that I think that's probably a very, very useful feature. Of course, I know people maybe argue, oh, this is not good. This is so annoying. I have to confirm all the time. Yes, of course. Some people probably don't want. So you may want to have a switch off on. Depends whatever their preference. So if some people switch off, the interface allows them to continue to draw whatever the reaction in whatever directions until they finish the whole reaction drawing. Then say adding another node here, reaction check, a check reaction, whatever. At that time, you take this whole schema, try to check each of step and confirm, maybe open another page and confirm user what is that right? Is that right? And let them confirm. Once they confirm, of course, you already have reaction information in the mapping sketch. Then you can let user do whatever they want. So that's my two suggestions here. Of course, I notice that things probably not going to that easy. For example, there might be a lot of issues. For example, this reaction, they put a solvent here, and this Weibit condition. Here, they're actually adding another reactant and try to generate a third product. And all these things probably getting quite complicated. My suggestion is, try to do one step at a time, and there's no perfect solution. The problem is we have no solution right now. Okay, if we have a solution, it's one step ahead. Good user interface and step-by-step approach, and collaborate with different industry. So, in summary of my seminar, I think one thing I did not put here is the ERM system I built in company. We rolled out last year, but immediately this year we are working on the second version. The reason we have that is because the outsourcing, the business is evolving in many companies. In BI, it's a new scenario. We don't know how to deal with. And while we are developing software, try to fulfill their needs, the business is already changing. So I feel like I'm quite kind of chasing the moving target. So the real information real thing I want to tell you is this is a new scenario and nobody knows how to deal with it. To manage this kind of workflow, it is challenging right now. So that's why we have version 1 and now we have version 2. In terms of the version 2 we're trying here, we actually use ChemAxon and can capture the schema and then regenerate it in whatever web interface. We can iterate the compound, and that's very good. In other software, it may can do, but probably it's still very difficult. But in ChemAxon JCOM, it's very easily achieve this goal. In Marvin sketch, there was many choice you can capture this reaction scheme. Although, to pass individual reaction, we have not able to do that right now. So my challenge here is, this is a big business need. I remember MDL ChemAxon actually built like a synthesis planning. I heard that, but I never see it. So think about the chemists maybe want to use this kind of interface to plan their synthesis. And if we can capture it and parse it and put it in database, that would be ideal. So I'm really looking for the ChemAxon to help us, and we really want to collaborate with you. Thank you.
Very interesting talk, Ben, especially this part about the discussion about the reaction scheme. And indeed, I know that my colleagues in the core team and the Marvin team have been thinking about this problem a lot, but they didn't come around to actually implement all their ideas. Mm-hmm. I have participated in many discussions in ChemAxon how to realize these things mm-hmm. that you mentioned, and it is really interesting to see how much need is for that one. So we are looking forward to further discussions with you and implement this feature.
Thank you.